we're going to continue looking at how to factor these sorts of trinomials, and we're going to have a few more easier ones than a few harder ones. So starting out, we have our x squared minus 3x minus 70, going to multiply, and we get 1 times negative 70 is negative 70. And separating those out and factoring, we're looking for numbers that multiply to be 70 but add up to 3. And so that kind of means that the numbers should be pretty close together. So we know 1 times 70 or negative 1 times 70, negative 2 times 35. 3 doesn't work, 4 doesn't work. Negative 5 times 14. 6 doesn't work, but 7 works nicely. Negative 7 times 10. And if you add these together, that's going to give you the positive 3 that we want. And so we can go right to the answer with this. We can write it as x minus 7, x plus 10. But just to illustrate using the factor by grouping method, we're going to go ahead and break 3x into x squared minus 7x plus 10x minus 70. And then we're going to group. And we know that x squared minus 7x has a GCF of x, so that's going to be x minus 7, and 10 and 70 has or negative 70 has a common factor of 10, and that's going to leave us with x minus 7, and then we have a common binomial of x minus 7, so that's going to be x plus 10, x minus 7, right? And by the way, since it's multiplication, it doesn't matter what order the two binomials go in. All right, so just making sure we know both ways as to how to factor these easier trinomials. All right, and again, it's an easy trinomial because there's a coefficient of 1 in front of the x squared. One last example, this one seems pretty easy. So we're going to take 1 times 25, right? And factors of 25 are pretty easy because there's only 1 in 25 and 5 and 5. And it just so happens that 5 plus 5 is going to give us 10, which is the magic number that we want. So these are going to be our two magic numbers. And so we can factor this into x plus 5, x plus 5. Again, only because there's a coefficient of 1. But let's go ahead and use the grouping method as well. So we're going to rewrite this as x squared. We're going to take one of our magic numbers, write it as 5x. We're going to take our other magic number, write that as 5x, and then we're going to bring down the 25. We're going to group, and fortunately they're all positive. So we're going to factor out an x, and we're going to factor a GCF of 5 from the second set. So that's going to give us x plus 5, plus 5, x plus 5. Right. Since 5 divided by 5 is going to give us just the x, and then 25 divided by 5 leaves us with 5. And we can factor out the common binomial of x plus 5, so it's going to be x plus 5 left over with x plus 5. Now, unfortunately, this one's not done because we have the exact same factors being multiplied by one another. All right, so we have an x plus 5, x plus 5. So another way to factor this completely is because you have the exact same binomials, you could write that as x plus 5 quantities squared. All right, and that's only true if you have the exact same binomials being multiplied. Now, there are some times where you have a coefficient in front of the x squared. All right, so for instance, now we have a number other than 1. And so what we're going to do with that is we're going to do the exact same process. So we're going to start by multiplying 5 times 8, and that's going to give us 40. And then we're just going to go down the list and try to find numbers that add up to 22. And so we know that number 40 is 1 times 40. And if we add that, that's going to be 41. So it's not those two. 2 times 20, if we add those, that's going to give us 22. So it looks like that 2 and 20 are the magic numbers. And what we're going to do is we're going to rewrite this as 5x squared plus 2x plus 20x, and then we're going to bring down the 8. All right, so all we did was we said 22 is 2 plus 20, right? Or 2x plus 20x. We're going to group, and then we're going to factor out a GCF of x and factor out a GCF of 4. for both of the binomials. So we factor in x, we're going to be left with 5x plus 2. If we factor out a 4 and divide this out, this is going to be 5x plus 2. And fortunately, we have a common binomial. We're going to factor that out, just like we've done before. And then we're going to be left with x plus 4. Now, I want you to notice that if you skip right to x plus 2, x plus 20, like we did before, that doesn't work. That's not the same answer as this, which is the correct answer. And so notice that the shortcut method that we were able to use if the coefficient was 1 in front of the square, and we could just jump right to the answer, works nicely for coefficient of 1, but it doesn't work if you have a coefficient other than 1. So that's why I was showing you the process before, so that way we could just get used to it. Okay? All right, a few more examples. Right? So we have this 2x squared minus x minus 15. We're going to multiply 2 times negative 15. We're going to get negative 30. And then we're just going to list out the factors of negative 30. And again, we have to be cognizant that because it's a negative, there's going to be twice as many factors. Right? So we're going to have negative 1 times 30. Right? And if we add that up, that's 29. And we're looking for negative 1. So the numbers should be pretty close together. Negative 2 and 15. And if we add those, that's 13. Negative 3 and 10. If we add those, that's 7. Negative 5 and 6. And if we add those, that's 1. And so remember, we can flip the signs around. So we would have 5 times negative 6. And if we add those together, that's negative 1. So those are our magic numbers. All right. So like I said, if you're good with your multiplication facts, then this is a pretty quick process. If you're not, then it's going to take a little bit longer to go through and try to find your magic numbers. All right. And you might just use your calculator. So now we're going to split this up. We have 2x squared plus 5x. Right, so we're splitting up the x squared into 5x minus 6x minus 15. I'm going to rewrite this as 2x squared plus 5x plus negative 6x minus 15. All right, so remember, the trick is that if this third term is negative, the GCF is going to be negative. Right, so right here, we're going to factor out an x. And we know that 3 divides 16 and or 6 and 15, but because the third term is negative, we're going to factor out a negative 3. Right? So we're going to have x quantity, 2x plus 5, minus 3, and this is going to be 2x plus 5 when we divide these terms out. Finally, we have a common binomial of 2x plus 5. We're going to factor that out as a GCF. Right? So that comes on the outside, and then we're left with x minus 3. Right. And I'll urge you guys to always check by foiling this out. Okay, so if you're not sure of your answer, you can always do your first out or inner last. Okay, just a couple more examples. Now this one's pretty tough, right? Because now we have 3 and 63. So this is where we might need to use our calculator to be able to help us out a little bit. Okay, so I'm going to take our 3 times our 63. All right, and that's just 189. I know that. So let me minimize this just a little bit so we have some room to work. All right, so this is going to be our 189. And this is where it gets a little bit tedious. Okay, and it's going to be negative 189. And we need numbers that add up to be this positive 20. All right, so let's just go ahead and take 189. And we know it's not divisible by 2, all right, because it's not an even number, but we can divide it by 3. And that's going to give us 63, which makes sense. So we would have 63 times negative 3. And if we add that, that's going to give us 60. All right, so that's not too close. We know it's not divisible by 4 because it's not even. All right. We know it's not divisible by 5. Let's try 6. So we have 189. So 189 divided by 6. All right, and that's 31.5, not even divisible. 189 divided by 7. So you can see the process here. All right, so that's 27. So that's going to be 27 times negative 7. All right, since we divided by 7. And that just happens to give us a 20. when we go through and add these together, right? So that's the process you might want to use if you start getting these really big numbers, is just go in your calculator, divide by 3, divide by 4, divide by 5. Try to use your multiplication facts to help you out with that, right? So we're going to split this up into 3x squared plus 27x minus 7x minus 63. Right? And again, because the third term is negative, we're going to rewrite this as 3x squared plus 27x quantity plus negative 7x minus 63. And now we can go ahead and factor out a greatest common factor. So this has a 3x and a 3x, and this has a negative 7 and a negative 7. Okay, so be cognizant that if the third term is negative, the GCF in that second binomial is going to be negative. 3x, and we're going to have x plus 9, negative 7, and we're going to have x plus 9. That's a good thing because now we can factor out the common binomial of x plus 9, and we'll be left with 3x minus 7. One last example of factor by grouping with the trinomials. So this one's actually not too bad. The numbers are fairly small, not like the last one. So we have 9 times 4, which is 36. And if we go ahead and factor 36, we're going to have 1 times 36. We're going to have 2 times 18. We're going to have 3 times 12, 4 times 9, and 6 times 6. Now, if we add these together, we're going to get 37, 20, 15, 13, and 12. And it's really close that these are going to be the magic numbers, except we need a negative 12. One thing to be cognizant of is that, remember that 2 negatives multiply to be a positive as well. And we need to get a positive 36. So couldn't we rewrite this as negative 6 and negative 6? And if we add those together, that's going to give us a negative 12 that we need, but it's also going to multiply to be positive 36. Right, so those are going to be our magic numbers, not the 6 and the 6, but negative 6 and negative 6. Right, so we're going to write this as 9x squared minus 6x minus 6x plus 4, or 9x squared minus 6x plus negative 6x plus 4. GCF for the first two terms is 3x. GCF over here, because we have a negative as the third term, is negative 2. Put a 3x on the outside, we have 3x minus 2, a negative 2 on the outside, and this is going to be 3x minus 2 if we divide those out. And so our answer seems to be, if we factor out the common binomial of 3x minus 2, we will be left with another 3x minus 2. And so our answer is not complete. Remember that if we have the exact same binomial next to itself, we're going to write that as the same binomial quantity square. All right, and that's the most simplified answer that we can get for this. All right, so lots of factoring, but factoring is a deep topic. So hopefully this helps you to see how to factor the GCF by grouping difference of squares, as well as the trinomials. And in our next video series, we're going to see why we actually use factoring.